If you work in networking or infrastructure long enough, you eventually hit this point where you crave an environment that isn't just, well, a dust-gathering, overgrown toy. So in today's Explainer, we're taking that random home lab, you know the one, maybe a router and a switch just sitting idle on a shelf, and we're transforming it into a disciplined, career-advancing enterprise environment. We're going to look at exactly how to build a setup that actually behaves like the environments you design and troubleshoot for a living, complete with real segmentation, redundancy, and authentic failure modes. It's going to be a lot of fun, so let's dive right in.
Right off the bat, we need to talk about a major mindset shift. On one hand, you've got the classic tinkering approach, right? That's your basic flat network with just randomly purchased hardware plugged in wherever it fits. But on the other hand, we have the enterprise lab. Now, here, everything is segmented by function, and we adopt what's called a spine leaf mental model, meaning every access point is just one hop away from the core. And here's the best part. You absolutely do not need a massive data center budget or a full rack of screaming enterprise gear to pull this off. What you actually need is deliberate design. You need a solid grasp of where a home setup has to compromise, and crucially, where it doesn't have to. So here is our blueprint for today. We'll start with rule number 1. Design first, shop later. Then, we'll dive into your virtualized server layer. Third, we'll tackle cooling, which is hugely underestimated. Fourth is power, to prevent total failure. And we'll wrap up with backup and redundancy thinking. All right, kicking things off with Phase 1, design first, shop later.
Seriously, you have to stop buying hardware before sketching out the topology. I get it, the instinct is always to grab the shiny new gear first and figure out how to plug it all together later. But that is entirely backwards. You need to sketch the network exactly the way you would map it out for a paying client. Map out your core, your distribution, and your access layers. And here's a little secret for you. It is perfectly fine if your core is just a single Layer 3 routing switch, and your distribution layer is just a virtual LAN boundary sitting on that exact same physical box. The actual physical hardware matters way less than the logical topology you design.
Picture this. Ask yourself this high-stakes question. What happens when a network link flaps? Or you're stuck troubleshooting routing between virtual networks at 11 p.m. on a Friday. A flat, completely unplanned network is never going to teach you how to handle those situations. But a real design? That exposes how your firewall rules and zero-trust segmentation actually interact with your routing decisions, rather than just how they look on some theoretical security policy document. There's this fantastic quote from the source material that hits the nail right on the head regarding intentional design. It says, even a two-switch, one-router lab can mirror a spine leaf mental model if you design it that way from the start. Segment by function, not by convenience. I absolutely love this because it perfectly captures the fact that even a minimal home lab can map cleanly onto those core, distribution, and access layers. It gives you the exact same mental framework you'd use in a massive multi-million-dollar enterprise deployment. Moving right along to part 2, your virtualized server layer.
Okay, so what exactly is the virtualization layer in this context? Well, it involves using a single mini PC, or maybe a repurposed enterprise server, running a hypervisor. And this allows you to spin up multiple software-based routers, firewalls, and entire test environments without having to buy separate physical boxes for every single one of them. This approach saves a ton of physical space in your home while offering incredible enterprise-level flexibility layered right on top of your physical lab. It's a total game changer.
Now, to actually make that virtualization layer work, practicing architects rely on tools like pfSense, OPNsense, or environments like Cisco CML or EVNG. These let you simulate insanely complex security and routing scenarios entirely in software. And let me tell you, this is genuinely how professionals keep their multi-homing and BGP skills, the protocols that literally route the entire internet, sharp between major client projects. They aren't testing on production gear. They test on a virtualized lab that behaves close enough to production to actually matter.
All right, step 3. This is a big one. Cooling, the underestimated factor.
Listen to this. Heat kills hardware and destabilizes performance long before it causes outright failure. Enterprise data centers spend millions of dollars obsessing over hot aisle and cold aisle airflow for this exact reason. Now, obviously, your home lab isn't going to have a dedicated cold aisle unless you really enjoy turning your coat closet into a sauna, but the core principle remains absolutely identical. You cannot let exhaust heat recirculate back into your intake air.
So how do we practically handle this at home? First off, just keep the equipment off the floor and away from the walls to actually allow some airflow. Second, if the space is enclosed like a closet, just add a simple exhaust fan. And third, Monitor temperatures with a cheap smart plug. Just a basic plug with a temperature sensor can ping you if your closet is quietly cooking your gear. You see? You absolutely do not need Tier 3 data center cooling to save your hardware from frying.
The whole point here is avoiding that slow, silent degradation of your hardware. Because if you ignore airflow entirely, I guarantee your switches will start to throttle under heavy load, your performance will mysteriously drop, and eventually, the hardware will just fail prematurely.
Which brings us to number 4, power, and how to prevent total failure.
Let me ask you something to really put this into perspective. What do you think happens to a hypervisor host or a NAS running RAID mid-write during a power outage that lasts just 5 seconds? Just a tiny 5-second blip.
Well, I'll tell you, the answer is corrupted file systems. It's devastating. A hard power cut mid-write can corrupt a file system in ways that a graceful shutdown never, ever would. This is precisely why real enterprise environments never run critical infrastructure without redundant power feeds and massive battery backups. And you know what? That reasoning isn't optional just because your home lab happens to be a little smaller.
Enter the uninterruptible power supply, or UPS. As the source material puts it, a UPS is the cheapest insurance you can buy against losing hours of configuration work to a tiny power blip. If you're just starting out, picking up a dependable, budget-friendly unit like an APC Backups is a fantastic starting point to ensure you aren't literally pulling the plug on your hypervisor mid-operation.
Now, here's your game plan for sizing and actually utilizing that UPS. First, calculate the actual wattage load of your switch, your router, and your servers. Do not just go by whatever wattage fits on the marketing label. Second, you want to prioritize a graceful shutdown over a super long runtime. In a home lab, you're rarely trying to ride out an hour-long storm. You just want to buy enough time to shut everything down cleanly. And third, you have to automate that shutdown process.
So how do we actually automate it? Well, we use something called Network UPS Tools, or NUT. This is a software automation tool that lets your hypervisor trigger an automatic, completely graceful shutdown the very moment your UPS hits a specific battery threshold. Implementing this automated path from power failure straight to clean shutdown gives you the exact same failover discipline that enterprise environments build in by default.
All right, the final piece of the puzzle, number 5, backup and redundancy thinking.
Look, we know you obviously can't replicate massive dual utility feeds to your house, but you can absolutely replicate the kind of redundancy thinking required for production networks. Try running 2 switches instead of 1, just to practice your spanning tree protocol and prevent network loops, or use MLAG to aggregate your links. Keep a secondary internet path. Honestly, even just tethering a phone hotspot works, so you can understand failover behavior. And crucially, make sure you back up your lab's configuration files off-box. Make sure they're versioned and recoverable, exactly as you'd expect to do in production.
Because here's the absolute best part about building your lab this way. At home, mistakes are cheap, but the lessons are permanent. A home lab built with real, disciplined design forces you to actually live with your own design decisions, and more importantly, your own failures.
And that is the real career payoff here. A disciplined lab teaches you practical, hands-on lessons that reading a textbook for a certification exam simply cannot do. You're going to be the one who finally tracks down that virtual LAN you forgot to route. You'll see firsthand how a power outage corrupts a VM because, well, maybe you forgot to test your UPS automation. You'll discover the cooling mistake that's quietly throttling your switch. These are the exact categories of problems you're going to deal with out in the real world.
So let me leave you with this final question. Are you ready to stop just assembling a toy and start actually architecting your enterprise lab? Start with the design. Build your virtualized compute right on top of it. Take your cooling seriously, and whatever you do, do not skip the UPS. If you take these principles and apply them to your own network, I promise you, you will watch your understanding of enterprise architecture absolutely transform.